Pumps. A pump is a machine which is used to raise or transfer the fluids. It is also used to maintain the constant flow rate or constant pressure. It is normally driven by an engine or a motor. Pumps are rated by the horsepower. Important specifications for pump: maximum discharge flow, maximum discharge pressure, inlet size, and discharges size. Pumps types. It is classified into positive displacement pumps and rotodynamic pumps. In positive displacement pumps, fluid is drawn or forced into a finite space and it is sealed. It is then forced out and the cycle is repeated. In rotodynamic pumps, centrifugal force is used to move the fluid into a pipe. Pumps reciprocating. Reciprocating pumps. It is a positive displacement pump. It uses a piston and cylinder arrangement with suction and delivery valves integrated with the pump. It can be single acting and double acting. There may be single or multi cylinders also. It sucks and raises the liquid by actually displacing it with a piston plunger that executes a reciprocating motion in a closely fitting cylinder. This page shows the single acting reciprocating pumps diagram. Pumps single acting. During suction stroke, the piston moves to the left, causing the inlet valve to open. Water is admitted into the cylinder through the inlet valve. During the discharge stroke, the piston moves to the right, closes the suction valve, and opens the outlet valve. Through the outlet valve, the volume of liquid moves out of the cylinder. This page shows the diagram of the double acting reciprocating pump. Pumps double acting. Each cycle consists of two strokes. Both these strokes are effective, hence it is known as double acting pump. Liquid is filled at one end and discharged at other end during forward stroke. During the return stroke, end of cylinder just emptied is filled and the end just filled is emptied. Pumps reciprocating. Advantages: relatively compact design, high viscosity performance, ability to handle high differential pressure. Pumps centrifugal. Priming of a centrifugal pump. The operation of filling the suction pipe casing and a portion of delivery pipe with the liquid to be raised before starting the pump is known as priming. It is done to remove any air, gas, or vapor from these parts of pump. If a centrifugal pump is not primed before starting, air pockets inside impeller may give rise to vortices and causes discontinuity of flow. Pumps centrifugal principle. When a certain mass of fluid is rotated by an external source, it is thrown away from the central axis of rotation and a centrifugal head is impressed which enables it to raise to a higher level. A rotating component comprising of an impeller and a shaft. A stationary component comprising a volute, suction and delivery pipe. Pumps centrifugal working. The delivery valve is closed and the pump is primed so that no air pocket is left. Keeping the delivery valve still closed, the electric motor is started to rotate the impeller. The rotation of the impeller is gradually increased till the impeller rotates at its normal speed. After the impeller attains the normal speed, the delivery valve is opened when the liquid is sucked continuously up to the suction pipe. Pumps centrifugal. Parts of a single stage centrifugal pump diagram is shown in this page. Pumps centrifugal. working. It passes through the eye of the casing and enters the impeller at its center. The liquid is impelled out by the rotating vanes and it comes out at the outlet tips of the vanes into the casing. Due to the impeller action, the pressure head as well as the velocity heads are increased. From the casing, the liquid passes into the pipe and lifted to the required height. When pump is to be stopped, the delivery valve is to be first closed. Otherwise, there may be some backflow of water into the reservoir. Pumps centrifugal types: volute, vortex, diffuser. This page also shows the volute centrifugal pumps diagram and the turbine centrifugal pumps diagram. Vortex casing. This page shows the diagram of vortex casing. Pumps centrifugal volute casing. In this type of casing, the area of flow gradually increases from the impeller outlet to the delivery pipe. Vortex casing. If a circular chamber is provided between the impeller and volute chamber, the casing is known as vortex chamber. Diffuser C. The impeller is surrounded by a diffuser. The guide vanes are designed in such a way that the water from the impeller enters the guide vanes without shock. It reduces the vibration of the pump. Diffuser casing. The diffuser and the outer casing are stationary parts. Diffuser casing. This page shows the diagram of diffuser casing. Turbines. Impulse turbine. Hydraulic prime mover is a device by which the potential and kinetic energy of water may be converted into mechanical work. It requires a continuous supply of water, so there should be a storage of water in a dam. The dam will maintain the supply of water in dry seasons too. Water is taken from higher level by means of penstock pipes to the prime movers.